Hello, I'm Haldane Dodd, Executive Director of the Air Transport Action Group. I'd like to take the next 15 minutes to answer this question. How can global aviation reach net zero carbon emissions by 2050? I'll do this by taking you through a series of underlying questions. But first, a bit of background. In October 2021, the global civil aviation industry became one of the first sectors to commit to net zero carbon emissions by 2050, in line with the Paris Agreement 1.5-degree stretch target. This was an increase in ambition over an earlier long-term goal. Importantly, the commitment is backed by almost all the world's airlines, aircraft operators, airports, air traffic management providers, and supported by the major names across the supply chain. The goal will be underpinned by a transition away from fossil fuels by mid-century, the research, development, and deployment of both evolutionary and revolutionary technologies, continued improvements in operational efficiency, and the use of carbon removals to deal with any residual emissions in 2050. Now, we'll explore all of these in the next few minutes, but I'd like to emphasize that the industry did not take the adoption of this goal lightly. Aviation is one of the hardest sectors to tackle, and we wanted to make sure that net zero was feasible. Now, it's a significant challenge, but it can be done. When planning a net zero pathway, it's important to see where you've come from and where you're heading to. Aviation has always prioritized improvements in efficiency. It's almost our business as usual mantra. Looking to our past, a flight that you take today will produce less than half the CO2 that the same flight would have in 1990. At a global scale, this means that we've already achieved efficiency improvements that get us to the blue line instead of the red one. These improvements will continue and hopefully accelerate. But we also know that without special measures, our carbon emissions, based on expected growth and connectivity improvements, will probably reach around 2 gigatons of CO2 in 2050. So it's our key mission to work out how we get from there down to net zero emissions. I want to illustrate the detail that we explored in order to understand where those carbon reductions will come from. Over a period of 3 years, 70 experts from across the industry split the task into 5 working groups, looking at things like traffic forecasts, developments in efficiency and innovation, and sustainable aviation fuels. Each of those working groups detailed many dozens of forecasts and potential pathways leading to hundreds of possible outcomes. Now, we concentrated on 3 illustrative scenarios, pulling levers in different ways to meet net zero carbon emissions at that global level. And these are outlined in our Waypoint 2050 report. I want to spend the next minutes going through 10 key questions that may be triggered when we say that aviation is going net zero by 2050. The first and most obvious is, can it be done? And the answer is, it is a significant challenge, but it is possible, and without resorting to substantial use of offsetting or carbon removal. The 3 waypoint scenarios show that depending on which levers you pull, it can be achieved primarily through advances in new technology and a shift to sustainable aviation fuels. So scenario 2 here shows a future where the technologies don't move beyond evolutionary improvements in conventional models, and most of the emissions reductions must be achieved through sustainable aviation fuels. Scenario 3 shows that split if we were able to rapidly deploy radical technology options like hydrogen and electric aircraft. And scenario 1 falls in between the two. Each of those scenarios uses a small amount of market-based measures to deal with residual emissions in 2050. And it's important to note, even if some technologies don't scale rapidly, we wanted to ensure that net zero was possible anyway. Question 2 is about offsets. At the moment, even though efficiency is improving all the time, the only way to significantly deal with today's aviation CO2 emissions is to offset that travel. Aviation is in fact the only sector in the world to have a global market-based measure to deal with the growth of CO2 emissions in the near term, and that's the CORSIA agreement, reached through the United Nations Specialized Agency, ICAO. But we also recognize that this is just a stopgap measure in the near term, while new technologies and sustainable aviation fuels scale up. By the time we get to 2050, we're going to need to deal with the remaining CO2 emissions that we have not been able to cut in the sector. And we're going to need to turn to natural climate solutions and carbon removals technologies, which will be a key part of the world's response to climate change. The IPCC recognizes the vital role that these options play. Now, there's a lot of buzz around new forms of propulsion, including electric and hydrogen as options for aircraft. A lot of work is taking place around the world right now, and we can expect to see some form of electric propulsion, either from batteries or hydrogen fuel cells, in the smallest commercial aircraft, so the 9 to 19 seat category, between 2025 and 2030. A few years later, these options may be available in larger model aircraft in the regional category, but there are some significant challenges to overcome, both the technology of the aircraft and the engines themselves, as well as the distribution and production of green hydrogen, which will be needed. Potentially a few years later, hydrogen options may be available in the short-haul market. A lot of challenges remain, but this matrix is a view of how these new forms of propulsion and energy might fit into the fleet over the coming decades. It should be noted, however, a majority of carbon emissions come from medium and long-haul flights, which make up 3/4 of CO2 and which will rely on sustainable aviation fuels for decades to come. So that leads us to the next question. Will shifting to sustainable fuels require large amounts of land or impact food or water use? And the answer is no. Aviation has adopted a sustainability-first approach, and the analysis that we've done removes all unsustainable sources as well as limiting availability of feedstocks that might have uses in other industries. It's a very conservative estimate. Today's sustainable aviation fuel, or SAF, comes mainly from waste oils and lipids, and over the next years, other waste sources will start coming on stream. Some use of cover crops can start being seen. These are grown in rotation with food crops and help to regenerate the soil in off years. And eventually, sustainable aviation fuel made literally from low-carbon electricity will become viable and take on more of an important role. Put a different way, you can see how these different pathways will evolve over the course of the next 30 years. Now, we're already starting to fly on sustainable aviation fuel today, very small quantities, but it's a solution which we know works, reduces CO2 emissions by 80% or so compared to our fossil fuels, and will improve to potentially 100% carbon reduction. It does not require new aircraft or changes to engines, and it's scalable. The biggest challenge today is cost. And that brings us to our next question. Will flying cost more in the future? Now, this is a challenging question to answer because there are so many variables that go into the price of an airline ticket. And efficiency improvements have resulted in significant reductions in the cost of travel and connectivity over the last decades. But we know that sustainable aviation fuel does cost more than fossil fuel today, up to 2 to 4 times as much. Analysis shows that cost can come down as these technologies mature. And this chart illustrates that. If you add in the cost of carbon, which is expected to increase, the cost of SAF will fall to within the spread of jet fuel prices that the industry has already experienced over the last 20 years. Aside from the SAF question, there may also be some cost differentials with radical new technologies like hydrogen and electric, but this also may be offset somewhat with efficiency gains. So if I were to make a prediction, I would say that the cost of flying may increase a little, but that we will still be able to connect the world and extend the benefits of travel to more citizens. Question 6 looks at whether we are waiting until 2050 to make any kind of improvements. And while a lot of the major technology breakthroughs are not available today, there are a lot of things that we're able to implement right now by doing things such as improving operations, flying our aircraft better, working together to implement small efficiencies, putting our aircraft on a diet by lightweighting seats and other equipment, and importantly, modernizing our air traffic management system with opportunities such as space-based navigation. Each of these efforts adds to overall efficiency improvements across the system and are an important venue for early action. In addition, we're already implementing sustainable aviation fuels, with over 365,000 commercial flights so far using a small proportion of this fuel. More production is coming on stream rapidly now, with 14 new facilities opening in the next 3 or 4 years, and a number of additional projects producing SAF before 2030. In fact, with the commitments from airlines for over $14 billion in offtake agreements, we can expect that over 6% of aviation fuel in 2030 around the world could be SAF. And this is just what's been announced so far. Now, in every Waypoint 2050 scenario, we're going to need substantial quantities of sustainable aviation fuel, up to 445 million tons or 550 billion litres per annum by 2050. As I outlined, we know where this could come from and what it will take to make it happen, but can it happen fast enough? We're going to need a concerted effort by governments and the energy sector to make this happen. But if you look at the trajectory of the solar and wind sectors and add in the urgency of the climate challenge, this is absolutely doable, with most of the action needed in the 2030 to 2050 period. Aviation will need low-carbon electricity for multiple uses in the next decades. For the direct use in smaller battery aircraft like those commuter aircraft in the 9 to 19 seat segment, to produce green hydrogen for use in some larger aircraft, and as part of the power-to-liquid SAF production process. In all, we believe this could require between 8 and 18% of the currently anticipated low-carbon electricity production across the world in 2050, but it's likely that aviation demand will increase overall supply of low-carbon electricity. So, why should governments support the energy transition in aviation? Our analysis shows that in order to meet our pathways towards net zero 2050, between 5,000 and 7,000 SAF production facilities might be needed across the world, although there is some consolidation that could take place. This allows energy industries to flourish in countries all across the world. In fact, almost every country on Earth could become an energy provider, a more decentralized system than the 22 countries which produce 90% of oil today. And because we fly everywhere, local opportunities could supply local airports. This will cost. Investment may be needed of up to $1.5 trillion over 30 years, but when you annualize that figure, it's around 6% of typical yearly oil and gas expenditure today. And importantly, this new energy industry will create or sustain up to 14 million jobs, 90% of which are in the supply chain for SAF production. Finally, what support does the industry need to make net zero aviation a reality? Well, we need support from governments, the right policy environments focusing on long-term thinking and smart regulations working with the industry. We also need governments to agree a long-term climate goal for aviation at the 41st ICAO Assembly this year, ensuring a strategic climate response is not just coming from within the industry, but it's also backed up by global government vision. The energy industry will also need to get serious about their transition away from fossil fuels and work with us as customers to deliver significant quantities of SAF. And both research institutions and our customers can also play a supportive role. Customers, for example, can offset their travel through high-quality UN-backed projects, or indeed more and more airlines are working with big corporates to allow them to help in the scale-up of SAF for their flights. So in conclusion, we've found through the Waypoint 2050 process that the industry's long-term goal of net zero CO2 from aviation globally by 2050 is very challenging, but it is achievable. We're going to need significant scale-up of sustainable aviation fuel, including investment to help build this new energy source. New technology, such as electric and hydrogen aircraft, need accelerated research and development, but they could enter service by around 2035, particularly on some short-haul routes. Operations and infrastructure efficiencies are vital for early action and to maintain capacity efficiency in the future. And offsetting is important in the near term, but net zero 2050 may still rely on some carbon removal options. So one bonus question for you: where can I get more information? The Waypoint 2050 report is available on our website, alongside the companion Fueling Net Zero report, which outlines the SAF pathways in great detail. And the industry's Fly Net Zero commitment is also online. Now, we welcome all help to make this ambitious commitment to flying net zero a reality by 2050. Thank you.